few maximum reaction are going through three intermediate, either carbocation, free radical or carb anion intermediate. So today we are going to study about the reaction intermediate, and we divided in three parts. Part 1 is carbocation, free radical intermediate, and another is carb anion. Now today's topic based on the carbocation. You already know that cation means positively charged. So carbocation means where carbon atom get positive charge. So where from we get carbocation? Let's go for that. Carbocation, we know that carbon is a tetravalent, means it has 4 valency. So one of, if any of them leave the substrate, leave the carbon, so carbon become positively charged. That's called carbocation. Now we can choose anything. Suppose if I choose CH3X, X is a leaving group. X is a leaving group. It may be halogen, ODS, etc. Okay. Now if X leaving with its own electron means bonding electron. We know that any covalent bond has 2 electrons. Now leaving group X, leaving the carbon atom with it both the electrons. So it is giving CH3 plus X minus. Now positive charge on carbon atom means it is a carbocation. Basically, based on these things, we make any carbocation. So just try to understand their classification. Based on the structure, the carbocation can be divided into 3 parts. Primary carbocation, yani 1 degree carbocation, 2 degree carbocation, yani secondary carbocation, 3 degree carbocation, yani tertiary carbocation. So for making those, you also need those substrate. Okay. Now go for that. As I already tried, CH3X, later I will find out C2H5X, CH3 isopropyl substrate, and this is the tertiary butyl substrate. So X minus going out from the substrate, taking both the electron. Okay. So it become methyl cation. Now here also same thing, it become ethyl cation. Here X minus, it is also giving you CH3 AH plus. This is the isopropyl cation, and X minus, it is giving you CH3 plus X minus. Now based on the structure or the bond or the carbon atom attached to the alpha carbon atom, we can divide it into 3 parts. It is called methyl carbocation, methyl cation or methyl carbocation. It is 1 degree. It is this level. Going for this one, ethyl 1. Ethyl 1 means CH3 CH2 plus. So now this is the carbon where positive charge situated. Now this carbon is attached to another carbon atom. So this carbon is known as, this cation is known as 1 degree or primary carbocation. Okay. Now we are going for this one. This is actually isopropyl carbocation. Isopropyl classification. Now we will go for the structure of the carbocation. So we can clean that one. We can clean the blackboard. From the both sides. Both sides means one nucleophile or any solvent. Okay, any solvent which has lone pair can attack above the plane or below the plane. Okay, so here is the high chance to get a mixture product. Okay, now if you start with any substrate which have R as nomenclature, okay, R or S. So you will get a mixture after the reaction for your solvolysis reaction or alcoholysis reaction. In case means solvolysis means you can take water, any kind of solvent. Even if you take water, then you call it hydrolysis. Okay. Now the thing is that you are getting two kinds of product at a time. Not a single compound you are getting at all. Okay. So we will come later on for this case. Now we are going for how we will find the stability of the carbocation for primary, secondary, tertiary, and if any other cation is there. Okay. Carbon atom, if push its own electron towards the positively carbon atom, it will be more stable, isn't it? Suppose a person who does not have money, you are helping her with the money, so he will be very happy, isn't it? But if a poor person begging something and you are trying to take money from him, so he will be very upset, isn't it? So here the same thing, you have to find some group which has positive inductive effect, means group who is giving its bonding sigma electron towards the positively carbon atom, that means carbocation. So H plus CH3 plus. Here those carbocation have been drawn. Now if you think that which one will be more stable according to inductive effect, if you think only inductive effect, then this tertiary carbocation will be more stable, then 2 degree carbocation, then 1 degree, and least is methyl carbocation. Why? Let's see. In this tertiary carbocation, okay, there is 3 methyl group, 1, 2, and 3. Okay. Now we know that methyl group or any alkyl group generally has plus I effect. Means this group there is a sigma bond. This is 3 sigma bond. Any sigma covalent bond has a 2 electron. You already know. Now this as methyl group has a positive charge, so it is pushing its own electron towards the positively charged carbon atom. Okay, I already told the person with the empty hand. There is a person with the empty hand and you are giving some money. Okay, so it is helpful matter to that person. So it is also happening here. Carbon is positively charged. Someone has been taken its own bonding electron from it, and another group present already in the molecule giving its own sigma electron, means giving its pushing towards it, not totally giving. So this is the one the stability factor. So here 3 methyl group H. Here we have 3 methyl group in this compound, so it is more stable. Now we will come here. Here is 2 methyl. Both have plus I effect. So it is also stable, but it is not stable like tertiary. It will be tertiary because here 3, here only 2. So obviously secondary or 2 degree isopropyl cation is less stable than the tertiary terbutyl group. Next is coming your ethyl cation. Now here it is only one methyl group who is pushing its sigma bonding electron towards the carbocation. So it is also stable but less stable than the 2 degree carbocation where it is isopropyl cation. Okay. Now least stable is methyl cation, because if you draw the methyl cation you find that there is no any other with carbon attached to that positively charged carbon atom. Okay. So this is the factor which is helping you to find out the stability of the carbocation. Next we are going for the same. I will give those examples for the hyperconjugation structure. How hyperconjugation helping the carbocations to be stable. Okay. Oh, I did not tell you. So any group which is pulling the electron from the carbocation will be least stable. Suppose if I draw any structure, suppose